A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hi. The world of sight is so beautiful, isn't it? Colorful flowers, the bluish sky, sunrise and sunset, a beautiful rainbow. Our world is such a big treasure of many diversities of colors. How do these color variations form? How do they appear to us? We are answering all these questions in this unit. How do we see objects using light? Yes, we see objects when light strikes an object and returns to our eyes. That's why we cannot see any objects in the dark. What happens after the light reaches the eye? There is a lens inside our eyes. The lens inside the eye is an element that helps our eyes form reflections or see objects. This is a convex lens. We already know that a convex lens is a type of lens whose refracting surfaces are bulged outwards. A convex lens converges the parallel light rays to a single point on the principal axis. The image will also be formed at this point. We often use a screen for catching the images in case of experiments related to lenses. But in the case of eyes, the image formed on the retina, which means the retina acts as a screen here. That is, the position of the retina coincides with the focus of the lens. Does the position of the retina changes as the distance from the object change? No. It is the focal length that is changing with the position of the object. How is it possible? As a result of the contraction of the ciliary muscles of eye, the focus of the lens is precisely adjusted to the position of the retina. That's the reason why we are able to see objects at different distances clearly. You should note one interesting point here. Convex lenses form inverted images. So, the image formed in the retina will also be an inverted one. This image becomes erect by the activity of the brain. Now, we understand how we are able to see objects at different distances. But can we see the object from all the distances? Let's find out. Try to read a book holding it very near to your nose. Can we see clearly what is written in it? We couldn't distinguish the letters, right? Now, if we slowly move the book away from our nose, we will be able to read the letters clearly when we reach a certain distance. By holding the book at least this distance, we can read it clearly. This distance is the minimum distance for clear vision or the least distance of distinct vision. Near point is the nearest point at which the object can be seen distinctly. The near point of an eye with a healthy vision is 25 centimeters. So, we can say that the least distance from an object to the eye should be 25 centimeters. If the distance is less than 25 centimeters, we cannot see it clearly. Like this, what is the farthest point an eye can see clearly? We can see the farthest trees and mountains and even the stars which are at a distance of light years. So, the far point is the farthest point at which the object can be seen distantly. The far point of an eye with a healthy vision is at infinity. Let me ask you one question. How do all the images fall on the retina of the eye clearly when we read a book or while we are looking at a star? Let's do an experiment to find out. Place a lighted candle at a distance of 13 centimeters from the lens. Do we get a clear image of the candle on the screen? No. Now, place lenses of focal length 10 centimeters, 15 centimeters and 20 centimeters on the lens holder without changing the distance between the lens and the screen. On using which lens is the image clear? Yes, the lens which has a focal length of 10 centimeters. If the distance between the lens and the screen is a constant, different lenses can be used to create a clear image on the screen. So, we have seen that we have to use lenses of different focal lengths for objects situated at different positions to get the clear image on the screen which is at a fixed distance from the lens. The eyes also have the same function, haven't they? In case of eyes, the distance between the lens and the retina is nearly constant. To get a clear vision, the image of the object from the far point up to the near point must be obtained on the retina itself. For this, the focal length of the lens in the eye has to be changed based on the distance from the object. When we look at nearer objects, the ciliary muscles related to the convex lens in our eyes are contracted and the curvature of the lens increases. The focal length decreases. While looking at far objects, the ciliary muscles are relaxed and the curvature of the lens decreases. The focal length increases. We have seen that the lens is adjusting the focal length by itself. The ability of the eye to form an image on the retina by adjusting the focal length of the lens in the eye by varying the curvature of the lens irrespective of the position of the object is the power of accommodation. So, in this session, we have learned how the image is formed by the eyes. Image is formed by adjusting the focal length of the convex lens of the eye with the help of the ciliary muscles.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ എൻക്ലാപ്സ് ദ ലേണിംഗ് ആപ്പ്.